faithfully conveying value and interpreting great books worldwide. Hello, this is Sally talking books. Today we're driving into the book The Rise and Fall of Pluto. In August 2006, explosive news came from Prague. At the IAU conference, members voted and decided Pluto was officially kicked out of the solar system's 9 planets. When the news hit, public opinion erupted in shock. For many, it meant the 9 planets memorized since childhood suddenly became 8. In places like the US, crowds protested against the IAU's decision. So, how did Pluto become one of the solar system's 9 planets? And why was it booted from the planet family? Today's book is a Pluto biography covering its past and present. Author Neil deGrasse Tyson is an astrophysicist, heads the Hayden Planetarium, and writes popular science. He earned NASA's top public service medal and made Time's 100 most influential list as an astrophysicist. Tyson focused on Pluto research and was among the first to push for its demotion. He spent 7 years writing The Rise and Fall of Pluto. Next, I'll cover the book's main points with 3 questions. First, how was Pluto discovered and named? Second, how did Pluto get removed from the planet list? Third, how should we think about Pluto now? Let's start with the first question. Pluto's discovery and naming. Before that, we got to look at how humans found planets over time. Our ancestors knew about planets long ago. At first, folks thought planets were mysterious things circling Earth. Back then, Chinese called the 5 visible planets the 5 stars: metal, wood, water, fire, earth. But the West counted the moon and sun too, making 7 planets. After Copernicus in the 1500s, people saw Earth isn't the center. The sun is the solar system's star, with planets orbiting it. As for the moon, it's not a planet, but a satellite orbiting Earth, so the planet count went from 7 to 6. With better astronomy tools by the mid-1800s, astronomers found Uranus and Neptune, making 8 planets in the solar system. That became the consensus. It got written into textbooks and became common knowledge. So beyond Neptune, is there another planet out there? Well, after finding Neptune, astronomers dove into searching for more, calling it Planet X. Back then, most astronomers believed Planet X existed because they saw Neptune's wobble. What's perturbation? What exactly is perturbation? Simply put, planets orbit the sun in circles, following Newton's gravity law. So, we can calculate exactly where a planet is at any time. If a planet's path or speed seems off, it's likely cause a big object nearby is messing with it. That's perturbation. If scientists spotted Uranus's wobble and predicted another big planet out there, that led to finding Neptune, the 8th planet. Neptune's own wobble meant another planet beyond, Planet X. But finding Planet X wasn't easy, because it's so far from Earth. Take Neptune, 58 times Earth's size, but 4.5 billion kilometers away. It doesn't glow, just reflects faint sunlight. Before its discovery, astronomers saw this dim dot in telescopes but couldn't confirm it was a planet. And Planet X is even farther beyond Neptune, making it way harder to spot. In 1894, American astronomer Lowell built Lowell Observatory in Arizona, focusing on hunting for Planet X. The way to search for Planet X is by comparing photos taken by telescopes at different times. Since the relative positions of stars in photos don't change, after ruling out known planets and comets, those moving suspicious dots could be Planet X. But finding differences in 2 photos with millions of bright spots is like finding a needle in a haystack. It's incredibly hard. Until 1916, when Lowell passed away, he still hadn't found Planet X. After Lowell's death, the observatory's search for Planet X didn't stop for a moment. Finally, in 1930, this mysterious Planet X was discovered by a young man named Clyde Tombaugh. Tombaugh was undoubtedly lucky. He was only 24 that year and had just started working at Lowell Observatory a year ago. On February 18, 1930, Tombaugh was comparing photos of the Delta Geminorum region taken in January when he accidentally spotted an extremely faint moving dot. Through precise calculations, they preliminarily confirmed it was Planet X beyond Neptune, which astronomers had been desperately searching for. Tombaugh then dug out decades of photos from the observatory, calculated the planet's possible location, and found traces of Planet X in many photos, further confirming the theory. The news of Planet X's discovery spread from Lowell Observatory to the U.S. National Observatory and major observatories in Europe, causing a sensation in the field. Because of this discovery, humanity's understanding of the solar system advanced further outward. According to international convention, the observatory that discovers a new planet has the right to name it. Interestingly, the person who named Pluto wasn't its discoverer, Tombaugh, nor anyone at Lowell Observatory, not even an American. It was an 11-year-old named Venetia Burney. This British girl, originally after Planet X was discovered, Lowell Observatory solicited names from around the world. One morning while having breakfast, Venetia heard her grandfather read her the news and blurted out, "Why not call it Pluto?" The little girl could come up with that name because she was studying ancient mythology at the time. In ancient Roman mythology, Pluto is the ruler of the underworld, the god of death who governs the entire dark empire. To the little girl, a planet so distant from Earth must be surrounded by utter darkness and nothingness, truly deserving the name Pluto. She just said it offhand. Her grandfather took it seriously. Coincidentally, he'd been a librarian at Oxford before retiring and was friends with astronomers who often researched there. So he told an astronomer named Herbert Turner. This astronomer had high standing in the field back then. Herbert valued the girl's idea, even wired Lowell Observatory to propose Pluto, and Planet X was officially named just that. The deity Pluto is called Ming Wang under Underworld King in Chinese, hence Ming Wang Xing Pluto star. Its naming wasn't due to authority. Actually, Lowell Observatory got over 1,000 suggestions worldwide. After multiple votes, Pluto won unanimously in the final three-way round. Two main reasons for consensus. First, all 8 planets were named after Greek Roman gods like Mercury, messenger god for its speed, or Mars, war god for its blood-red appearance. Pluto fits perfectly, the underworld god representing that distant, cold, dark void. Second reason, some wanted to name it after Lowell Observatory's founder, but that was rejected for breaking the naming pattern. Yet Pluto's PL coincidentally matched Percival Lowell's initials, so it perfectly honored this pioneer of the Planet X search. From the 1930s, Pluto became the solar system's 9th planet in textbooks worldwide, entering public astronomy knowledge. All right, we've just covered the book's first question: how Pluto was discovered and named. Astronomers had searched for the solar system's 9th planet for ages. In 1930, young American astronomer Clyde Tombaugh finally discovered it by comparing telescope photos taken at different times. The planet beyond Neptune, dubbed Planet X, was officially named Pluto after British schoolgirl Venetia Burney suggested it, following naming rules in a vote. So how did Pluto get kicked out of the Planet Club? Now let's dive into the book's second question: understanding Pluto's demotion process. Truth is, astronomers debated Pluto's planetary status for decades without pause. You could say doubts about Pluto's status began the very day Tombaugh discovered it. First, let's clarify. When we say 9 planets, we mean versus asteroids. Actually, before Pluto's discovery, astronomers had found thousands of small solar orbiting bodies between Mars and Jupiter. These objects are tiny, just tens of kilometers across, with Ceres topping at 950 kilometers, dwarfed by real planets. So astronomers class them as asteroids. After finding Pluto, Tombaugh optimistically sized it up, thinking it must be massive to disturb Neptune's orbit. He believed Pluto had to be huge, at least Neptune-sized. But back then, they only had ground telescopes for size estimates, leading to huge errors. As observation tech improved, Pluto's measurements got more precise. By the 1970s, scientists realized Pluto was under 0.6% of Earth's size. Mercury, smallest of the 8 planets, is 10 times bigger. Even Earth's moon dwarfs Pluto. Plus, better measurements showed Neptune's orbital wobbles weren't as strong as thought. This further proved that Planet X beyond Neptune, Pluto, wasn't particularly large. Pluto isn't just small, its orbit is unique too. The other 8 planets have near circular orbits and mostly orbit the Sun on the same plane. But Pluto's orbit is a flattened ellipse, tilted at a 17-degree angle to the other planet's orbital plane. What's more special is that its orbit actually crosses Neptune's. What does that mean? Imagine the other 8 planets orbits like 8 circular lanes on a track field. Runners won't collide if they stay in their lanes. Pluto's orbit is bizarre, like adding a ninth lane on the outermost edge. But its shape is completely different from the other 8. Some parts are way beyond the stadium, far from other lanes. Other sections actually cross the 8th lane. Luckily, Pluto commutes smart. It avoids Neptune at crossing points, preventing collision with the giant. This made Pluto seem eccentric to astronomers, but not enough to challenge its 9th planet status. That the Kuiper Belt discovery thrust Pluto's status into controversy. What is the Kuiper Belt? It was first proposed in 1972 by Irish astronomer Gerard Kuiper, hence the name. Thomas, initially hypothetical, it was later confirmed through observation. Simply put, beyond the 8 planets lies a zone with many Pluto-like bodies, small with unusual orbits. These are called Plutoids, and their collective is the Kuiper Belt. Since the 1990s, astronomers have found thousands of objects there. If other Kuiper Belt objects were much smaller than Pluto, it'd be manageable. But unfortunately, astronomers soon found a large body, Eris, discovered in 2005. Eris resembles Pluto, slightly less massive but physically larger. Not only that, astronomers found more large bodies in the Kuiper Belt, like Haumea and Segna, just slightly smaller than Pluto. If Pluto is the 9th planet, then Eris, Haumea, and Sedna would be the 10th, 11th, and 12th planets, right? Then comes the question, if these Kuiper Belt objects are big enough to be called the nth planet, then large asteroids in the Mars-Jupiter belt, almost as big as Pluto, similar in size to Haumea and Sedna, should also qualify as major planets. Soon we'd have hundreds or thousands of planets in the solar system. That's why since the 1990s, including author Tyson, people proposed demoting Pluto. Some suggested reclassifying it as an asteroid. Others proposed a new category, Plutoids, for Kuiper Belt objects like Pluto. In 1998, the IAU met to discuss Pluto's demotion. Back then, most astronomers supported keeping Pluto as a planet. The resolution failed, with many providing justifications. Some argued Pluto should remain the 9th planet because, like the 8, it's a perfect sphere. Actually, most celestial bodies over 800 kilometers in diameter become spherical due to gravitational collapse. Sphericity is space's most stable shape. Even moons like ours are spherical, so it can't justify Pluto's planetary status. Others claimed Pluto's 5 moons should qualify it as a planet. But Mercury and Venus have no moons yet, are planets, so that reasoning fails too. Astronomers even found tiny asteroids with moons, like Ida in the asteroid belt, potato-shaped and just 40 kilometers long, yet it has a 1.4-kilometer satellite. So having moons doesn't prove Pluto's planetary status either. More and more astronomers recognize the need to reclassify Pluto, especially after the discovery of Eris in the Kuiper Belt in 2005, which is larger than Pluto. After that, the demand for reclassification became even more urgent. Because of this, at the 2006 International Astronomical Union meeting, most scientists voted to strip Pluto of its status as the 9th planet. The debate over Pluto's status wasn't just in astronomy circles, It sparked strong reactions among the public, especially in the US. After the 1998 IAU vote, American media and citizens kept arguing about Pluto's place. The book's author, Tyson, also became a focus of public attention. It started in 1999 when he was director of the Hayden Planetarium at the American Museum of Natural History. In the science exhibit hall's solar system model, he only showed the 8 planets, omitting Pluto, which upset many Americans. The New York Times even reported on it, questioning the Hayden Planetarium. New Yorkers and the media loved Pluto so much because it's essentially an American star. But why do they say that? First, Pluto's discovery was America's first world-impacting achievement in astronomy, making Americans proud. Many Americans even idolized its discoverer, Tombaugh. Moreover, Americans love Pluto's name. As mentioned, it's called Pluto in English. In Disney cartoons like Donald Duck and Mickey Mouse, Mickey's pet dog is also named Pluto. Coincidentally, the dog Pluto first appeared in cartoons in 1932, linking the cute pet to the distant planet, becoming a memory for generations of Americans. Childhood memories, suddenly demoting Pluto from the 9 planets. They found it hard to accept. The author received many protest letters, including from kids, like a third grader who wrote, "Dear Mr. Tyson, why do you think Pluto isn't a planet anymore? I don't like your explanation. Pluto is my favorite planet, and I want you to take back all the books and revise them." This kid didn't just use 7 exclamation points at the end. They drew a picture of Pluto crying. The protest wave reached its peak after the IAU announced the 2006 vote results, with Tyson facing relentless media and public pressure. That year, in Tombaugh's home state of New Mexico, they even passed legislation rejecting the IAU decision, declaring Pluto still the 9th planet there. But as we discussed earlier, demoting Pluto had solid scientific reasoning. American sentiment couldn't justify holding back scientific progress. After calming down, the public and media gradually accepted Pluto's demotion. All right, we've covered the second question, how Pluto was removed from the 9 planets. Pluto is one of the larger Kuiper belt objects, with properties distinct from the 8 planets. If we counted it as a planet, many Kuiper belt and asteroid objects would qualify too, though its demotion sparked controversy and emotional resistance. But science prevails. Pluto's demotion won majority support among astronomers. You might wonder, what exactly were the reasons for demoting Pluto? If it's not a planet, what is it? Let's tackle our final question. What kind of celestial body is Pluto? Astronomers ultimately classified Pluto as a dwarf planet. Dwarf as in small. To understand this, we need the official planetary definition. To strictly differentiate the 8 planets from Pluto and similar bodies, the IAU standardized planetary criteria in 2006. Not every sun-orbiting object is a planet. Planets specifically refer to Venus, Mars, Earth, etc. These major planets must meet 3 conditions. First, it must orbit a star. Second, it must be large enough, typically over 800 kilometers in diameter, and spherical. Third, it must have enough gravitational dominance to clear its orbital path of other nearby celestial bodies. By this definition, all 8 planets, including Earth, qualify. Take Earth. First, it orbits the Sun. Second, its diameter exceeds 12,000 kilometers, forming a near-perfect sphere. You might ask, isn't Earth's surface full of bumps? With 8,000 meters peaks and 10,000 meters trenches, how can it be perfectly spherical? I'll tell you, it really is remarkably perfect. Mountains and trenches are negligible compared to Earth's massive size. If scaled down to a billiard ball, Earth would feel smoother than an actual one. The third criterion is most crucial, and Earth nails it perfectly. Only Earth orbits the Sun in its path. The Moon is its satellite. This is how Pluto got excluded. The third rule disqualifies Pluto. Though it meets criteria 1 and 2, it shares its Kuiper belt orbit with similar-sized bodies like Eris, Haumea, and Sedna, unable to clear them. Bodies meeting criteria 1 through 2, but failing 3, are called dwarf planets. Besides Pluto, Eris and Haumea in the Kuiper belt, plus Ceres in the asteroid belt, are classified as dwarf planets. Smaller objects can't collapse into spheres due to weak gravity, remaining irregularly shaped. These are called asteroids. Pluto's dwarf planet status doesn't diminish its scientific importance. In fact, in 2006, the year of its reclassification, NASA launched New Horizons specifically to study Pluto. Carrying some of Toomba's ashes, New Horizons reached Pluto in 2015, giving humanity its first close-up view. Pluto is a celestial body over 2,300 kilometers in diameter, made of rock and ice, with ice taking up more volume than rock. It's freezing, averaging minus 220 degrees Celsius, with no signs of life. Yet Pluto seems like a soulful planet. It didn't coldly ignore humanity's arrival. In New Horizons images, people discovered a massive, heart-shaped, dark spot on its southern hemisphere, like a friendly gesture to humans. Astronomers named this region after Toomba, showing Pluto isn't lonely. Beyond its dwarf planet companions in the Kuiper belt, it has its largest moon, Charon, always walking hand in hand. Charon, over 1,200 kilometers wide, more than half Pluto's size, has over 10% of Pluton's mass. Their 20,000 kilometers separation, 1/20th Earth-Moon distance, causes mutual tidal locking. What is tidal locking? Like how we only see one side of the moon from Earth, its orbit and rotation sync due to Earth's gravity. The moon orbits like a loyal guard, always facing Earth. That's Earth tidally locking the moon. Pluto and Charon are mutually locked, always face to face. Their orbits are like cosmic lovers, holding hands, eternally gazing at each other. From Pluto, Charon hangs motionless in one spot of the sky. Same goes when standing on Charon looking at Pluto. A bridge built at their closest point wouldn't twist or collapse from their motion. Many astronomers argue Charon isn't a moon but a dwarf planet, Pluto's equal. Unlike Earth's moon, orbiting around Earth's center, Pluto and Charon revolve around a shared point in space. So Pluto and Charon actually form a binary system, unique in our solar system. Some might think that even without planet status, Pluto is still the solar system's most distant point. But actually, New Horizons reaching Pluto doesn't mean it reached the solar system's edge. Beyond Pluto's Kuiper belt lies the vast Oort cloud. Astronomers believe it's filled with icy rocks and debris, the birthplace of comets. Just how enormous is the Oort cloud? In astronomy, the average Sun-Earth distance is called an astronomical unit, AU. The Kuiper belt where Pluto resides is 30 to 50 astronomical units out, while the Oort cloud extends to at least 100,000 astronomical units. Sunlight takes nearly 2 years to reach there. New Horizons, after flying by Pluto, will continue exploring deeper into the solar system. That concludes the book's third question. What kind of celestial body is Pluto? Pluto is defined as a dwarf planet because it hasn't cleared other bodies from its orbit. In 2015, New Horizons reached Pluto, giving us unprecedented knowledge about it. Pluto and the Kuiper belt aren't the solar system's outer boundary. The solar system extends nearly 2 light years out. That wraps up the rise and fall of Pluto. Its discovery, planetary status, and demotion reflect humanity's growing solar system understanding and astronomy's progress. Pluto's demotion marks astronomy's advancement. Science is always evolving, as is humanity's solar system and cosmic exploration, with more discoveries anticipated. All right, that's our journey through the rise and fall of Pluto. Check audio notes below, and we'll meet again for our next great book.